So, next this is another example. So, here actually it is not asked, you can check that it may be satisfying all the relationship, all the properties. So, here it is asked that the joint CDF cumulative distribution function of a bivariate random variable xy is given by this fxy of xy is 1 minus e to the power of minus alpha x, 1 minus e to the power of minus beta y. So, let us do that, x greater than equal to 0, y greater than equal to 0. So, this fxy of xy, it is defined as of a bivariate random variable, it is defined as 1 minus e to the power of minus alpha x and 1 minus e to the power of minus beta y. It is 1 minus e to the power of minus alpha x into 1 minus of e to the power of minus beta y. Whenever x is greater than equal to 0 less than infinitive, y is greater than equal to 0 less than infinitive, alpha beta greater than 0 and 0 otherwise, 0 otherwise. So, this is the cumulative distribution function of a bivariate random variable, it is given. So, you can check that when it is x goes to infinitive, this goes to 1, y goes to infinitive, this goes to 1. So, that is why it will be goes to 1, and x goes to infinity, y goes to infinitive, it is always between 0 and 1, because e to the power of minus alpha x for x positive, alpha also positive, alpha beta positive, it will be between 0 to less than 1. So, that is why 1 minus this will be between 0 and 1, 1 minus this also it will be between 0 and 1. Also, we can check that other properties also, properties of a cumulative distribution function, that will be a CDF. Now, question is that here it is not asked, it is already given that it is a cumulative distribution function of a joint of a bivariate random variable, it is given. Find the marginal cumulative distribution functions of x and y. So, it is asked marginal. Marginal means whenever it will be asked the marginal means it is a distribution of a subset of the random variable. So, the marginal distribution, what is the formula? So, the marginal cumulative distribution function of x is given by, so marginal cumulative distribution function is given by fxx, that is nothing but probability that x less than equal to x. So, how we can find this value? So, by definition we have already discussed that it will be found by taking limit of the other coordinate, limit y goes to infinitive fxy of xy. So, y goes to infinitive fxy of xy, this is nothing but fxx. So, then this is now if you take the limit at y goes to infinitive, then you can see that this is, it is very straightforward, e to the power of minus beta y, beta is a positive number, y goes to infinitive, then this becomes 0. So, that is nothing but this is become 1 minus e to the power of minus alpha x. So, another step we can write limit y goes to infinitive, because this is in the positive number. So, this is, it will be alpha x into 1 minus beta y, alpha x minus 1 minus beta y, sorry 1 minus e to the power of minus beta y, 1 minus e to the power of minus alpha x into 1 minus e to the power of minus beta y. So, this is goes to beta y goes to at y goes to infinity, beta is positive number. So, this goes to 0. So, this goes to 1. So, this is nothing but 1 minus e to the power of minus alpha x. So, whenever x is positive, otherwise whenever x is negative, then we cannot take this function, this will be 0. So, that is why when if given by this is nothing if x is positive actually greater than equal to 0 less than infinitive. So, this is we can write like this. So, finally, we will write, so this is equal to whenever x is greater than equal to 0 less than equal to infinity at 0, then it will be whenever it is x is less than 0 greater than minus infinity, this value will be 0. So, this will be whenever we will write a distribution function, we have to write the whole range. So, what is the value f x x is given by, we will write properly, x is 0, x less than 0, x less than 0 greater than minus infinity, x greater than equal to 0 less than infinity, then 1 minus e to the power minus alpha x. Similarly, you can find the marginal distribution function of y. Let us compute that. The marginal cumulative distribution function CDF of y is given by f of y. So, probability that y less than equal to y. This is equal to limit x goes to infinity f x y of x y. So, this is nothing but limit x goes to infinity. So, basically 1 minus e to the power of minus alpha x, 1 minus e to the power of minus beta y, if y is greater than equal to 0 less than infinity, it will be 0 if y is less than 0 greater than minus infinity. So, this will be the limit which can be written as, so I am just 0 first, because y this range from the left hand side, and whenever it is greater than 0, then we will take this function, and whenever x goes to 0 infinity, then this goes to 1, because e to the power alpha is a positive number, e to the power of alpha x it will goes to 0. So, this will goes to 1. So, this will be 1 minus beta y whenever y is greater than equal to 0 less than infinity. So, this is the marginal cumulative distribution function of this joint distribution. Now, so that x and y are independent random variable. So, how we can show what is the definition that two random variables are independent. So, we have to show that f x y of x y, this is equal to f x x f y y for all x y belongs to real number. So, since if x both are positive, y also positive, then f x y of x y is nothing but 1 minus e to the power of minus alpha x, 1 minus e to the power of minus beta y, which is nothing but this is nothing but f x x into f y. Now, for any other cases, this left hand side will be 0 if suppose x is less than 0 greater than infinity, or y is less than 0 greater than minus infinity, the left hand side also 0, f x y of x y, this is 0, which will be, see, whenever x is less than 0, then f x x will be 0, and if y is less than 0, then f y y will be 0. So, for any other case, this or this, any other cases, both are 0. Hence, f x y, hence f x y of x y, this is equal to f x x into f y y for all x y belongs to the real number. So, which implies x and y are independent random variable. Hence, we can see that x and y are independent random variable. So, this is another question. So, next question is that find probability x less than equal to 1, y less than equal to 1. So, let us find that probability of x less than equal to 1, comma y less than equal to 1. So, by definition, this is nothing but f x y of 1, comma 1. So, because definition is like this is nothing but probability of x less than equal to x, comma y less than equal to y. So, put x and y are 1, then x less than equal to 1, y less than equal to 1 by definition. So, this function we know, this function is e to the power of minus alpha into x 1, and e to the power minus beta into 1, this is 1. So, this is straightforward. So, now next question is that find probability of x less than or equal to 1. This is also same, because we know that f x, because it is we have to use the marginal cumulative distribution function, probability of x less than or equal to x. Hence, probability that x less than or equal to 1, this is nothing but f x of 1. So, f x of 1 we have already found what is the cumulative distribution function of x. This is 1 minus e to the power x greater than 0, here 1 minus e to the power of alpha. So, 1 minus e to the power of minus alpha x. So, this is e to the power of minus alpha. Then next problem, this is also straightforward, probability x less than or equal to 1. This is coming f x on 1, which is equal to 1 minus e to the power of minus alpha. So, next probability that y greater than 1. So, similarly, probability of y greater than 1, if we take the complement, this is nothing but y less than or equal to 1. So, y less than or equal to 1 we know, this is f y of 1. So, f y 1 is nothing but 1 minus of beta y. So, this is 1 minus of beta 1. So, 1 and 1 cancel, e to the power of minus beta. So, that also straightforward, just you have to take the complement. So, next problem is find x greater than small x, y greater than small y. It is small x, small y, two real number. For x, y belongs to real number, find probability x greater than x, y greater than y. Note that it is not just a complement of x less than or equal to x, y less than or equal to y. Basically, what we want to say, y greater than y, this complement is not equal to x less than or equal to x, y less than or equal to y. We cannot not just say that find the probability, this is 1 minus of this, we cannot not say, we will see that. So, that is why it is if we think that it is like just a straightforward, we do that complement of this, then it is may not be true. So, if you want to complement, so how we can find this probability of x greater than x, y greater than y. So, it is nothing but, suppose if you do the complement of this, so this will be 1 minus probability of x greater than x, comma y greater than y complement. So, complement. So, first of all we first write down. So, this is the event, nothing but probability that x greater than x complement intersection y greater than y. So, for all x y belongs to this real number, probability that x greater than x, y greater than y, this is 1 minute, sorry. So, this will be nothing but x greater than x intersection y greater than y. Now, if you want to find, because we know the probability in term of f x y of x y, this is probability that x less than or equal to x, y less than or equal to y. So, it is better if you try to find the complement of this, then we will get this type, but it is not just directly take complement of that, we have to use some other result also. So, this is nothing but 1 minus of probability that x greater than x intersection y greater than y whole complement, just this is the whole event. Now, this is A, this is B, A intersection B complement, we can write A complement union B complement. This is one theorem, you know, sorry, this is whenever we are taking whole complement, here we are using this result theorem. So, A intersection B complement, this is nothing but A complement union B complement, that result we are using. This is nothing but 1 minus of probability. So, x less greater than x complement is straightforward, x less than equal to x union y less than equal to y. So, this is some A union B, then 1 minus A union B formula, we know that this is x less than equal to x plus y less than equal to y plus minus A probability of A plus probability of B minus probability of A intersection B, x less than equal to x intersection means comma y less than equal to y. So, then finally what we got, 1 minus probability of x less than equal to x minus probability of y less than equal to y plus probability of x less than equal to x comma y less than equal to y. So, this is 1 minus of f x x, this is marginal probability cumulative distribution function, minus 1 minus of f y y plus f x y of x y. So, this is finally what we got. So, basically just initially just we wanted to say that this is not just equal to 1 minus probability of x less than equal to x, y less than equal to y. Like in univariate cases it is straightforward like that, like 1 minus f x y of x y, but it is not correct. So, it is not coming like this. So, you can see that it is not coming this thing. So, we are coming like probability of x greater than small x comma y greater than small y is nothing but 1 minus f x x minus f y y plus f x y of x y. So, this is the what we found cumulative distribution function finally. So, this is some numerical example we discussed, cumulative distribution function, what is the marginal and distribution function, how to find if they are independent, how to check that whether they are independent or not, and then finally we found we discussed that how we can compute some of the probabilities using this cumulative distribution function, joint cumulative distribution function and their marginal cumulative distribution functions. So, next we will discuss the discrete bivariate discrete random variables and bivariate continuous random variables, their probability mass function and their probability density functions. Now, we will discuss the joint probability mass function of two discrete random variables. So, whenever x and y both are discrete random variable, then the bivariate distribution we say discrete bivariate distribution function. Analogous to the univariate cases, whenever x is a univariate random variable and discrete, then we discuss the probability mass function. So, probability mass function is probability at a point x equal to xi. So, you can remember that whenever let x be a discrete random variable, we define the probability mass function PMF of x is defined as probability that x is equal to x for all x belongs to the real number. Now, we can define for all x, but it will be 0, it will be, so Px what is the, this is always less than equal to 1 greater than equal to 0, some of the properties, and we know that Px of x is not equal to 0 whenever x is equal to xk for some k belongs to 1 2 like this. So, basically xk is nothing but the range of x, x1 x2. So, some k it is x1 x equal to xk, otherwise this is 0 if x does not belongs to xk or x does not belongs to, we can say, a range of x. So, if x does not belong to range of x, this is 0. Now, this is some of the properties also you can remember that we discussed summation of Px of xk, all possible values of k, this should be is equal to 1. How we will find the cumulative distribution function? X from probability mass function, this is nothing but if you take all k xk, sum over you can take all k which k less than equal to x, Px of xk. So, this will be 0 when x is minimum values of less than minimum values of this range x1, suppose the minimum, if we write in a ascending order. So, then x1 will be minimum, if small x is less than x1, then fx of x will be 0. So, that we already discussed, all this concept we discussed, and also if you know the probability mass function, you can find the cumulative distribution function, and if you know the cumulative distribution function, so then the probability mass function also you can find. So, that is Px of the minimum value, suppose fx1, so this is nothing but fx of x1, and then for any other value Pxk, it is nothing but fx of xk minus fx of xk minus 1, where for k is greater than 1 less than So, for any other integer values infinitive, but k is a natural number. So, here, so 1, 2, 3, 4. So, that is why you can find the, if you have cumulative distribution function, you can find the probability mass function also. Now, for joint distribution, joint random variable, let x y is a, let x y be a bivariate discrete bivariate random variable. So, basically both are discrete bivariate random variable with the cumulative distribution function f x y of x y, this is equal to probability that x less than equal to x, y less than equal to y. The joint probability mass function of x y is given by p x y of x y. This is nothing but probability that x equal to x comma y is equal to y. So, now basically this will be 0 if suppose we consider range of x r x y is the range. So, this is basically contain the all the number x, we can write I y j, I is equal to 1 2 like this, j is equal to 1 2. So, this is equal to 0 if x y does not belongs to r x y, and it is actually non-zero. So, that is why we can write p x y of x I y j, this is nothing but probability that x is equal to x I comma y equal to y j for I is equal to 1 2, j is equal to 1 2. For any other values x I and y j, this will be 0. So, that is the probability mass function, it is defined here. P x y of x I y j equal to p probability that x equal to x I, y equal to y j, and the function p x of x y is called the joint probability mass function. So, joint probability mass function. So, we have already mentioned here. So, what are the properties of this joint probability mass function? The joint probability properties of the joint probability mass function, properties. First of all, it is the probability p x y of x I y j, probability that x is equal to x I comma y equal to y j. Note that what is this comma? So, this is nothing but probability that the event x equal to x I intersection y is equal to y j. So, several times we have discussed this. This is a event x equal to y, x equal to x I is a event, and y is equal to y j also event. So, x is equal to x I, this is event corresponds to S belongs to sample space, because x is a random variable means it is a measurable function from S to R. So, all S satisfying x of S exactly equal to x I, and y is equal to y j are the, this is all S belongs to S such that y of S is equal to y j. So, these are the event, and then if you take the intersection of these things, so this is nothing but probability that x is equal to x I intersection y is equal to y j. So, this is the probability joint probability mass function. Since this is a probability, so probability by axiom 1, this will be always less than equal to 1, greater than equal to 0. This is one properties, here it is mentioned. Like analogous to univariate, you discussed the univariate also, sum of all the possible values, this should be is equal to 1. So, here sum of all I and j, probability of x y, x I y j, this should be is equal to 1. So, this is a certain event, because you are considering all possible values the random variable x can take and y can take, and the probability of sum of all this probability. So, this should be is equal to 1, and this is like if you want to find the probability x y sum of the, so some probability that x and y, this random variable belongs to A. So, A is a subset of this range x I y j. So, this will be nothing but summation of actually I and j, summation over all I and all I j, summation of I and all j, such that x I such that x I and y j, this belongs to this range. So, this is nothing but all possible values that x I and y j, such that this is inside A. So, this is nothing but all the possible values I and j. So, this is p x y of x I and y j, such that we can write all possible values of x I and y j. It is inside, actually the notation, it is little different notation, x I and y j belongs to range of A. So, it is written x I and y j should be belongs to range of A. Basically, here A is a element subset of x, or what is A actually? A here nothing but all element in S, such that x of x I is belongs to S, x of x I, all S belongs to S, such that x of S is nothing but x of S belongs to this range of A, and y of S belongs to. So, in a different way we can write, sorry. So, this is nothing but actually x of S is equal to x I, y of S y j, and then x of S comma y of S, this element should be belongs to range of A. So, range of A is a subset of the this range space. So, now I hope you have understood that, and then we will discuss how we can find this cumulative distribution function if you know the joint probability mass function.